Hello everyone, so today we are going to solve GFG problem of the day, which is count set bit. So the problem statement is simple, like we have a given n, okay, and we have to find the total set bit from 1 to n, like 4 is there. So for 1, okay, like in 1, okay, like 4 is there. So what from 1 to 4, 1, this is 1, this is 1 2, this is 1 3, and this is 4. So how many set bit are there? Set bit 1 2 3 4 and 5. So answer would be 5. We have to do same. So now if we say like we are going to going through a loop, and for each number, like whatever the number is, suppose at a time it is 5, okay. So we are going like at least like this, if you see the constant, then n is 10 to the power 8. So that means we can go in range of our int, like 2 to the power 32, that means 32 bit. For that means in 32 bit we are going to do going to check like whether that is a set or not, and we are going to calculate. So if we solve like that, so if I want to show you what I mean, like this one, for int I equal to 0, I less than, sorry, from 1 to n now. So I equal to 1, I less than equal to n, and I plus plus. Now we have to find that in this number, okay, in this number how many set bit are there. So if we can see like this the number equal to I, okay, so number is less than equal to n and number plus. Now we can have the bit up to 32, so we can go like 4 int bit equal to 0, bit less than 32, and bit plus plus, okay. Now we have to count the set bit, so we can write our int count, okay. So int count equal to 0 whenever we found a set bit. How we find? Like if we have a number and one of left shift of bit, what this is, like, okay, so when a bit is 0, then 1, okay, so when the bit is 0, what it means? That means that would be 1, okay. When bit is 1, then that become 1 1 1 bit, sorry, when the bit is 1, then this become this one, because one left shift of 1. If bit is 2, then this become 100. So whenever we do the end with the number, so only all the place except this one would be 0, and this place will be decided by our number. If the this bit of our number is also 1, then that is going to be 1, otherwise 0. So we can conclude like if this one num and this one, so if this value is greater than, okay, 0, that means that have also the 1 at that bit, and that is going to contribute. So this our count will be count plus plus, and we are going to return count. But okay, this is going to give I think TLE. Okay, now so we are going to if we talk about the complexity, then this become n into log of, and sorry, n into 32 bit, that means 32 into n, okay. Now if we if you want to optimize this solution, so now what we think, okay. So now instead of going to each number, we are going for a bit, like if for int I equal to 0 to 32, and I plus plus, like for each bit, like whatever the number is, for each bit, like 4 is there. So what is the things was there, like 0, then 1, then 1 0, okay, then 1 1, okay. So now, so what we do, like at first bit we will check how many set bit are there, so in which that 2 set bit is there. In second, how many set bit? 2 to, okay. So 4 is also there, so this one become, okay, yeah. So the 0 is not there up to, okay, yeah. So if we see, and at the bit 0 2 set bit, at bit 1 2 set bit, and here, so total would be 5. So now the question is how we will do, okay. So before solving the question, I'm just making you to like find some, when we write a binary number, some pattern. So whenever we write the binary number, we generally follow one rule. Like suppose if we, this is 0 and then 1, so what are our next number would be? So the next number will contain 0 and 1 with 0 and 1. Like what I mean like, now the next bit would be like 0 with 0 comma 1, and next it become 1 with 0 comma 1. What that is, it means like, so this become, first we will make it with 0, so this is 0, this is 0. So first both number come with 0, so this become 0 0 and this become 1. Then that number will come with 1, like this one is 1. Okay, now another one, the same things will come with like 0, and this one is 1, right? Now if we talk about the next number, now what our like these things, now these things is going to repeat. So like for 0 these all four things come, and for 1 these four things will come. Okay, so for, and now if we predict our next four number, then that it will be 0 0 0 0 0 1 0 1 0 0 1 1. Now if we talk about the next, now we have done with 0, now we start with 1, so 1 0 0 1 0 1, in this way. Okay, so now instead of writing all this, I want to show you. Okay, now if we see here, okay, so before solution, okay, I'm going like this one. So initially we have 0 1. Okay, so now what can be the possibility, like these two come with the 0 or 1. So if this will come with zeros, okay, so this become 0 0 with 0, this becomes 0 1, with 1 this becomes 0 1. So these are the number. Now if you want to use this, so now this section, this complete section, this fourth section will come with first 0, here see, then it will come with 1, like this. Okay, now if we take over the next, like what after this, so after this, okay, so now this become, whatever this number became, okay, like up to 7. Okay, this 1 1 1. Okay, so this is going to come with 0, and then this will going to come with a 1. So simple thing is like whatever the number we get, that will now come with the 0 then 1, in that way. Now if we say, I say you to find a pattern, so when we are on bit 0, so the number will repeat after like 0 1 0 1 0 1 0 1. So this size, this repeating size would be 0 1, sorry 2. Now when we are on bit 1, so the repeating will be start with the size 4, that means 4 4, that you can see the packet of 4 is there. Now when bit is 3, sorry bit is 2, so then this repeating would be 8. Okay, so that things I have do. So first things that in I have done, like I am going to find the size which is going to, after which the things is going to repeat. Okay, so for I said like for bit 0 there is a size would be 2, for bit 1 size would be 4, for bit 2 it would be 8. So how I write size equal to 1 left shift of bit plus 1, that means if bit is 0, so 0 plus 1, that means this will be equal to 2. So if bit 1, then 1 left shift of 2 become 4, and if bit is 2, then this become 1 left shift of 3, that means 8. Okay, so this one. Now one more thing, if we see in each packet like this 0, in first bit we know the size is 1, the size is 2, so half of the size is 0 and 1, like say 1 0 1 1. Now if we see the size of this pad, for bit 1 the size is 4, so 2 0 2 1. If we see the size of 8, like this one, the size of 8, okay, so in this half, that means 4 is 0 and 1. So one more thing that I need to calculate is half is just the half of size. So now we have size and half. Okay, now when we, okay, now we are going to find like on a particular bit how many cycle is there. So like if suppose if you this one is 4, okay, this is 4 now, and total n is 17, so how many cycle would be there? So we are going to like n by size, because if you are on a suppose if you are on a bit 1, so one bit means bit 1 means size is what, size is 4. Okay, so if size is 4, so then how many cycle? So 17 by 4, that means 4 cycle is there. And if 4 cycle is there, so we know in each cycle, if cycle size is some x, then in that half, that means x by 2 would be 0 and x by 2 would be 1. So half, that means we can multiply our cycle with half, like, okay, so what it contribute in the, that means half. Now one more thing is there might be after some, after cycle there might be some left. How we will deal with that, we will see, okay, later. So now I think we are clear. Okay, now let's try to, for n equal to 17, let's try to run this, okay, try run this. Okay, so now for initial bit, for bit 0, whatever the size is 2, okay, and what the half is, half will become in 2 by 2, that means 1. Okay, now how many cycle is there? There is just up to 17, 0 to 17 is there. Okay, 17 is there, so 17 by 2 is 8. Okay, so now, so that means cycle if we count also, so you see that the one thing should come in mind, that this got left. Okay, so this is just suppose if more number is there, suppose this is 18, this should be 18. So what, one we need to 18 by 2 9, so we are going, okay, because if you go to count this 1 2 3 4 5 6 7 8 is there, but you can say like this is also, so this should be 9. Okay, right? So now if the things is like 118, 18 by 2 is 9, this is just due to even and odd things. But if we miss this also, so this will come in remainder section, and we are going to calculate that, which we will see later. So for now, what we are doing, we are just doing that total n by size. So 17 by 2, that is 8. Okay, that means we have 8 cycle, and for each cycle, if the cycle size is okay 2, so half, that means one is, that means one is, one bit is 1 and another digit is 0. So we are going to do full into half, so 8 cycle is there, and into 1, that means 8 1. So we can see also up to here we have 8 1. Now we need to check like remainder. So what we up to here we are fine, so we now go to check the remainder. So what the remainder is, n modulus 2, that means 1. This 1 simply means 0 and 1. Okay, so now, okay, so now up to here if we see, that means we are done with there. So we need to check these two numbers. What this, like if we are on n equal to 0, we need to check this one and this one. Okay, so we are done with this 15, not 16. So we are going to calculate this 0 and this 1. So we are going from 0, and we have, that means 1 0 and 1 1 for now. So for now just we use this formula. Later I am going to explain this formula. So now that's remainder. So remainder, okay, this remainder is greater than equal to half. Okay, and for a basic at which I will explain later, for now you can assume that for we are remainder, that means if remainder is greater than half, then it's only going to contribute, because you know if there is a size x, then initially 0 to x by 2, or we can say -1, that is going to be 0, and then later would become 1. Like if we are there is like, if you say in the size of 4, there is first 2 0, then 1. In this, the first 4 0, then 4 1. Okay, so now what is the remainder? Remainder is 1. Okay, minus what is our half? Half is 1 1 1, so that means what, this is going to contribute to 1. So for now our answer become 9. Now when we come on bit 1, so when we come on bit, how many cycle is there? If we see, then 4 cycle. If we calculate, so 17 by 4, that means 4 cycle is there. And what is the size? That means size 4, so half become 2. So what this become, how much it is going to contribute? 4 into 8, 4 into 2 8, and earlier 9 was there, so total it becomes 17. Now if we calculate remainder, so 17 modulus 4 equal to 1. So this remainder is not less than half. That means if we see like this bit, we have that means 2, that means 1 means, that means 0 and 1 is there. So these two are left, but this can't contribute, because we know, okay, because we know that its cycle is 4. Okay, and it is its half is 2, and it's this is less than, okay, it's a, that means this, now the next number is 0 0 is there, now 1 1 would be there. So if the number one more number is there, that is going to contribute, this is not going to contribute, so we are leaving for that. Now if n equal to 2, then this become a cycle of 8. Okay, so now what the half become like 72, and cycle size, half cycle is, this one is 4, so this again is going to contribute, okay, 8, where that is, yeah, this one 8 to 17 8, this is 25. So this is going to be contribute. Okay, and if you take over the remainder is 1, again that remainder is less than half, so that is not going to contribute. Okay, now if we talk about this bit 3, okay, so if we take over the bit 3, again the size is 16, so half, okay, one cycle is there, so 1 into, okay, one cycle is there, 1 into half is 8, so 1 into this is 33. Okay, now remainder is 1, again remainder is less, because we know up to half there is only going to the 0, then 1. Okay, now for bit, the size is 32 and half is 16. So cycle, what, how many cycle is there? To 17, but 0 cycle there, so 0 into half, that is 16, that is going to contribute 0, so total is 33 for now. Now if we talk about the remainder, so remainder is like 17 modulus 32, which is 17. Now the thing is there, when we are on bit 4, so the size is 32, but our number is up to 17 also. So in first 16 means 0 to 15. So in 0 to 15 it is going to be 0, and then in 16 17 there would going to 1. So now Now, if we use our formula like remainder, okay, remainder is 17, 17 minus half, half is 16 plus 1, okay, so that is going to be okay, like 17 minus 16 plus 1, that is going to 2, so we are going to add 2 in our answer, so our answer will. Now if we go for now bit 5, so bit 5, that means size 64, so they are always going to give you the 0 cycle, so 0 into half is going to 0. And if you talk about the remainder also, that when the number become less than half, then that is automatically become 0, so this is also not going to contributing. So up to now 32, that is not being going to be contributed. Now the thing is like how we are using this one, that remainder minus half plus 1. Okay, so as I say, like when our remainder was 17, right? So now for 0 to 6, okay, when we talk about the half 16, okay, so actually in 16 1 will come, because on 0 to 15, 0 to 15, that means 16 digit is there, so 0 to 15 it would be 0, and from 16 to later there would be 1. So if we do like remainder is 17 and 17 minus 16, so this will get only this one, this will get left, so we are adding 1, we are adding 1 because we also want that half, okay, half, whatever the half is, like this 16 is also, we also want this one, because our calculation are up to here also. Now if we code, okay, we get more clear. Okay, so we have 32 bit. Now what, in each bit what we want to do, we want to find the total number of set bit, okay, and what we have discussed, okay, so in discussion we need to find first the size, then half. Okay, so if we talk about the size, the size, we know if for 0th bit there is 0101 dps, so size is 2, so what we are doing, one left shift of bit plus 1. Okay, yeah, so this is size, that means if this is 0, or you can also use in power of 2. Okay, now if you talk about the half, what half become size, size by 2. Okay, or we can like what we can write, one left one left shift of bit, same. Yeah, now our thing, how many cycle is there, so int cycle equal to, now whatever our n is, n by size. Okay, so this is going to calculate the cycle. Now what our answer is, so later int answer equal to 0. So now answer equal to how many, okay, answer plus equal to how many cycle is there, so cycle into each cycle is going to contribute the half of its side, which is half, to cycle into half. Now the thing is, we are talking about the remainder, so int remainder equal to, now n modulus what, n modulus size, so this is going to be the remainder. Now what, now we are going to check whether this remainder section like is going to contribute or not. So if this remainder, okay, it's greater than either or equal to, why we equal to, as we say, like if exactly like if in this scenario, okay, so like if only there is a 16, okay, also there, so 16 also is also going to contribute 1, right? Because for the first 0 to 15 it is going to be 0, and next it is going to be 1, so this one. So if remainder is greater than equal to half, okay, so it is going to be contribute. Okay, now how much it is going to contribute, so answer plus equal to, now remainder minus half, but we are also including remainder, so we will just one add. Okay, now if we, now what we are going to do, now we are going to return answer. Okay, so actually instead of I have used bit, so okay, they make this bit. What's the answer plus, okay, so this is answer plus equal to, what can be the issue, yeah, these things, I think it had the range of it is going out of range, out of in range, so they might be creating issue. So if we make it a small, or we can make it like long. So if for now, if I decrease it, because if it is less than 31, 31 plus 1 32, so this is going to create the issue. So now I think it should work. If we submit. Okay, so if we talk about the complexity, okay, so we went from 0 to 31, that means 32. Okay, and otherwise we have done nothing. So the complexity of big O 32. Okay, thanks for watching.